Hello guys, welcome on Tesla Adventures. As I have received many requests on my YouTube channel and personally by the current students which are studying from me, that sir please upload the videos like video lectures of surface tension and viscosity before JEE Advanced 2025. So I'm starting the uploading of surface tension and viscosity lectures from today itself along with the fluids. So fluid will be continued with these lectures, and we'll be completing it by maximum 10th May. Okay, this is the maximum deadline. So I would try to complete it before that. So, starting from the first lecture in this one, we will be discussing the main cause of viscosity and surface tension. So, the main cause of viscosity and surface tension is the cohesive and adhesive forces. So basically, mainly it is the cohesive force which is the main cause of surface tension and viscosity, but we will be discussing adhesive forces also. So actually, the force acting between the molecules of same material, like if we talk about the molecules of H2O in the water, so those molecules are bonded with some force, and that force is called as cohesive force because they are the molecules of same material. But if we dip a cotton cloth into water, then we will observe that water will be absorbed in that cloth. So that absorbing force which is applied by that cotton molecule on the H2O molecule is called as adhesive force, because these two molecules are of different materials. So the force of attraction acting between the molecules of same material is called as cohesive force, while the force of attraction acting between the molecules of different materials is called as cohesive force. In fact, adhesive force. So for same molecules it is cohesive force, and for different molecules it is adhesive force. So you must have seen that Fevicol or any glue is also called as adhesive. This is due to the fact that if we imagine that we have pasted these two wooden blocks by Fevicol in between them. So what is the scenario in the molecular level? That this molecule is this red one. This molecule is the molecule of Fevicol, which is applying the adhesive force on the wood. This is the wood block. So this is at this point adhesive force is generated, and again the other molecule is applying the adhesive force on the wood block, and they are together binded by the cohesive force. So they are applying the cohesive force at this point. So these two wooden blocks are binded together by the combination of cohesive and adhesive forces. So actually the force of attraction, weak force of attraction acting between the molecules of same material is called as cohesive force, while the force of attraction acting between the molecules of the different materials is called as adhesive force. First of all. Second is the important thing that this cohesive force also includes weak van der Waals forces and hydrogen bonding, while adhesive force includes the electrostatic attractions also. And the formation of a water drop, you must have seen that water drop is round in shape, and that round shape is due to the cohesive forces inside the water molecules. And if you split some water on the surface of wood or something else, that water will spread and it will be absorbed entirely on the wood. So that is due to the adhesive force that is applied by wood molecules on the water molecules. Okay, now let us discuss that what is viscosity. So just imagine that if we are just moving, you all know that air applies a certain friction on all the objects which are moving relatively to the air. So we know that meteors are not fired up in the space. In fact, when they enter the Earth atmosphere, they move against the air friction, due to which heat is generated, and then they got fired up and they catches the fire. So this is due to the air friction, and we have also studied that in electrostatics, that the cloud electricity or the static electricity in the clouds is also due to the friction of air, which is also called as viscosity. So you can also perform an experiment in which you can drop a tennis ball on the pool water, and you will see that till the ball is in air, it will be moving with higher velocity, and as soon as it will move inside the water of the pool, then it will attain some constant and very slow velocity, and that is also due to the liquid friction, which is also called as viscosity. So any fluid which is either gas or any liquid applies some frictional force or resistive force on any material which is moving inside that fluid with respect to that fluid. That is called as viscosity. And this viscosity is obviously due to the intermolecular forces, which is cohesive forces. So the macroscopic effect of cohesive forces together is called as viscosity. So let us see that this is a wide river. In fact, we can take an example of river Ganga in Haridwar. So it is a wide river and it flows in layers, which means that the velocity of the molecules in the bottommost layer of the river is slowest, because it is in contact with the ground and ground is applying a higher amount of friction on that layer. And as we will move from down to up in the uppermost layer, the velocity of the uppermost layer will be highest, and this is due to the fact that the uppermost layer is far most away from the ground. Okay, so the velocity of river Ganga in Haridwar is different at different layers. So let us suppose that this is the topmost layer and these are the molecules of the topmost layer. So the molecules of the bottom layer are moving slowly as compared to the top layer, because as we will move up, the velocity of the layers will increase. So these molecules of the bottom layer will apply a force on the faster molecules in the backward direction, and this force is obviously cohesive force. So because they will be applying cohesive force on each other, but as the upper molecules are moving faster, so the cohesive force will be dragging the molecules of the upper layer in the reverse direction. So the lower layer is actually applying a preventive force or a resistive force on the upper layer and lower layer is dragging the upper layer in the backward direction. This force is called as viscous force and the effect is called as viscosity. Now let us discuss the velocity gradient. To calculate this viscous force, we would require velocity gradient. Now we all know that the gradient of anything is its rate of change with respect to the distance. So as we have already discussed that in wider rivers, the river flows in layers, or we can also say that the flow is laminar flow. So as we will move up, the velocity of the layer will keep on increasing. So velocity gradient is the relative velocity of two layers divided by the separation between those two layers. Okay, so this is now by separation I means that center to center distance. Obviously there is no air gap between the two layers, but by separation I mean that the center to center distance, which means that this is the layer which has exact this velocity v plus dv, and this is the layer which has exact velocity v. So the difference of this velocity or the relative velocity, which is dv, divided by their separation is called as velocity gradient. Now velocity gradient, the flows can be classified into two forms, in which the velocity gradient is constant and the other form is in which the velocity gradient is variable. So you can see that in these two cases, velocity gradient is throughout constant, and it would be v naught by h in this case, and it would be constant through between these two layers, between these two layers, between these two layers, and all layers. And the velocity gradient in this flow is v1 minus v2 by h, and it would be constant, it would be same between these two layers, these two layers, these two layers. So velocity gradient for these two flows is constant, but the velocity gradient for this flow is variable. Okay, so we can say that as we will move in the upward direction, velocity gradient will increase, and by that I mean that if we move a distance of dy here, the change in velocity is dv, but if we move a distance of dy here, the change in velocity might be 2 dv, because velocity gradient is variable. Okay, now again we'll be discussing that this layer, the lower layer molecules, are slower as compared to the upper layer molecules. So lower layer molecules will be dragging the upper layer molecules in the backward direction, and that cumulative force, the total force applied by these two layers on each other, is the viscous force, and that is equal to minus neta a dv by dz or dy, where neta is called as coefficient of viscosity. This is coefficient of viscosity, and A is called as area of contact of layers, area of contact of layers, and dv by dy is velocity gradient, of layers. Okay, so this negative sign represents that this force is opposing the change in velocity. It is obviously dragging the lower layer, is obviously dragging the upper layer by this force. So this force is opposing the change in velocity of the relative velocity of the two layers, like friction does. So this is the force, viscous force, and in the next video we'll be discussing this case in which the plank will be moving on a layer of liquid which has some height, and we have to find out the amount of force required to keep moving this plank with some constant velocity. So by using that viscous force, we'll be doing this problem. Thank you.